Starting in the late 1700s, there began to accumulate some modern evidence for the atom. We'll be focusing on the work of Antoine Lavoisier and John Dalton and looking at their contributions towards our modern understanding of what an atom looks like. This is Screencast 4.2. Antoine Lavoisier had in his possession one of the world's most precise balances. Think of it as one of the world's first scientific instruments, and he was able to use it to do various experiments. In addition to discovering 23 elements, he eventually determined that when combustion reactions are performed, mass is actually conserved. This is demonstrated by this sort of image here. So you imagine a combustion experiment going on, and all the gases needed for the reaction and all the gases produced are trapped. In fact, the mass does not change, and this implies a lot of things. Gases have mass, but most importantly, mass is conserved in a chemical reaction and leads to the concept that an atom is in fact indestructible, at least based on this experiment. Our symbol for Antoine Lavoisier is the two-pan balance. Some 80 years later or so, John Dalton was performing similar experiments on atoms, and imagine him doing a reaction where magnesium is mixed with sulfur to make magnesium sulfide. This is not the precise experiment he performed, but it gives you an idea of the sorts of concepts that he was drawn to. In this case, one atom magnesium combines with one atom of sulfur to make one molecule of magnesium sulfide. Interestingly, if you took 24 grams of magnesium, it does not combine with 24 grams of sulfur. It combines with 32 grams of sulfur to make 56 grams of magnesium sulfide. What can we conclude based on this sort of model experiment? We could conclude that mass, sure, it's conserved, that's nice, 24 plus 32 is 56, but you could also conclude that an atom of sulfur is 25% larger than an atom of magnesium. These are the sorts of concepts and experiments that Dalton was concerned with, and this is visualized here. We've overemphasized the size of the sulfur atom for dramatic effect. And really he's talking about bonding, in this case a 1-to-1 ratio. Atoms are combining in small whole numbers. In fact, to this day, we've never really observed more than, say, 6 chemical bonds attached to a molecule, and even that is rare. An atom, I should say, at one time. Our symbol for Dalton is the earring, and it's this hook here which represents the chemical bond, and the earring itself represents atoms. This is some early evidence for the atom, and this is Screencast 4.2.